Hello everyone, welcome to our YouTube channel. With this video, we begin the new series of videos about derivatives. Please stay tuned and let's take this interesting trip together. So let's begin. So derivatives it's actually all about slope. Do you remember the formula for slope? It is change in y over change in x on our as you can see here, it's change in y over change in x, which is equal to delta y over delta x. Okay, so x changes from x to x plus delta x. This is the amount x changed, and y changes from fx to fx plus delta x, because when you put this value of x instead of x here, you will get f of x plus delta x. So now our slope formula will become like this, which is equal to fx plus delta x minus f of x over delta x, because when you put these values instead of this, you will get this one. So of course you don't have to memorize this formula, but this is very important for you to understand the logic behind this topic, derivatives. So let's solve one example about this one and you will understand better. Now let's look at this example. Here we have f of x is equal to x squared. So maybe you know from your classes the derivative of fx of x squared here is equal to 2x, right? So let's see how we get this answer by using the previous formula that we learned. So let's do that. Here we know the value of f of x, which is equal to x squared. So what was the slope formula? It is fx plus delta x, okay, minus fx over delta x, right? So here I know f of x, and this delta x, it will stay as it is for now. And now we can find the value of f of x plus delta x. So how we can write this? Fx plus delta x, which is actually equal to, we will put here x plus delta x instead of x. So it's x plus delta x squared. This is equal to x squared plus 2 times x times delta x plus delta x squared. Okay, so here when we look at our formula, it's minus fx. So we found the value of this, and now let's continue with this one. So this is minus fx, which is equal to minus x squared, right? So this is minus x squared over delta x. Okay, so here these x squares, they cancel out each other, and then here we will have 2x delta x plus delta x squared over delta x. If I take parentheses of delta x here, I will get delta x in the parentheses of, it's 2x plus delta x, right? Because here we have delta x squared, so 1 is here, so it will be 2x plus delta x over delta x. So these delta x, they cancel out each other, and here we have 2x plus delta x. Then as delta x heads toward 0, since this was 0, and here we will get 2x as our answer. Okay, so the derivative of is commonly written as d over dx. Okay, so as you can see here, we have d over dx, x squared is equal to 2x. This is also another notation used for the derivative of, this is also very common, which is f prime of x is equal to 2x. And here we have f prime of x is equal to y prime is equal to df over dx. This is equal to dy over dx. This is equal to d over dx f of x, and this is all equal to d over dx y. Okay, all these are equivalent and represent the derivative of fx with respect to x. So let's continue with the power rule. So what is power rule? So here we have f of x, okay, which is equal to x to the power of n, some power of x. So here n does not equal to 0, okay. This n can be positive, negative, but it cannot be equal to 0. So the derivative of this f prime of x is just going to be equal to n times x to the power of n minus 1, okay. So basically you take this power, okay, so you take this power and multiply it by the expression, and then you reduce the power by 1. Okay, so let's look at this example. Here we have f of x is equal to 5 times x to the power of 4. So we take this exponent in front of this expression. Okay, it's 4 times 5 x to the power of 4 minus 1, which is equal to 3. Okay, don't forget to reduce this power by 1. Okay, so here we will get 4 times 5, it's 20, is 20 x to the power of 3. So let's look at this example. Here gx is equal to x to the power of minus 19. Same logic, you just put this minus 19 in front of x, so it will become minus 90 times x to the power of minus 90 minus 1, it is minus 91. Okay, so here we have tx is equal to x to the power of 3.4. So again, same logic, 3.4 you put in front of x, so it's 3.4 x to the power of 3.4 minus 1, it is 2.4. The derivative of a constant. So let's see b our constant, okay, here. So for f of x is equal to c, the derivative of f of x is equal to 0. Okay, so wherever you see a constant, you know that its derivative is equal to 0. So let's look at this example. Here we have f of x is equal to third root of x plus 7. So here, when we take its derivative, okay, so instead of third root of x, I can actually write this as x to the power of 1 over 3, right? It's the same thing. So plus 7, so we don't write this. Why? Because I just learned that the derivative of a constant is equal to 0. So since 7 is a constant, I know that its derivative is equal to 0, so I don't need to write this here. So we do this kind of questions part by part. I first did this part and then second part. So let's continue. So let's write it as 0, and then here x to the power of sorry, I need to take its derivative, of course. So how do I do that? I just learned the power rule, right? So how do I do that? I put this exponent in front of x, which is equal to 1 over 3x to the power of 1 over 3 minus 1. Okay, so here we will get 1 over 3x to the power of, it's 1 minus 3, it's minus 2, so it will become minus 2 over 3. So this is the answer for our example. Let's continue with this example. Here we have f of x is equal to 4x to the power of 3 minus 5x squared plus x minus 1, and the derivative of f of 2 is asked. So first, in this kind of question, first you find the derivative of f of x, and then after that we put 2 instead of x. So let's do that. So here, how do we find the derivative of f of x? This is equal to, we will apply the power rule, right? So we put this exponent in front of this value, and it will be 3 times 4x to the power of 3 minus 1, right? We subtract 1 from this exponent, and after that it is minus, we put this exponent in front of 5x, so it is 2 times 5x to the power of 2 minus 1 plus x, this is equal to 1, okay, because this is x to the power of 1, so it's 1 times x to the power of, let me write this like this, 1 minus 1, and this is a constant, that's why I don't need to write it because its derivative is equal to 0, right? So let's continue. Here we have 3 times 4, it's 12, so it's 12x squared minus 10x plus, this is x to the power of 0, x to the power of 0 is equal to 1, right? That's why it's 1 times 1, it's equal to plus 1. So now we found the derivative of f of x. So now we will put 2 instead of x. So let's do that. It's equal to 12 times 2 to the power of 2, it's 4, minus 10 times 2, it's equal to 20, plus 1. So here it's 48, minus 20 is 28, plus 1, this is equal to 29. So how we take the derivative when we multiply by constant? So here the derivative of c times f is equal to c times the derivative of f. So let's look at here. We have d over dx, 5x to the power of 4. So here this 5, actually we can put this 5 in front of this d over dx. Okay, so we can write this as 5 times d over dx dx x to the power of 4. Okay, so this is equal to 5 times, what does this mean? This means the derivative of x to the power of 4, right? So let's take its derivative. We put this exponent in front of x, so it's 4 times x to the power of 4 minus 1, which is equal to 3, right? So this is equal to 5 times 4, it's 20, x to the power of 3. Okay, so let's look at this sum rule. The derivative of f plus g is equal to f prime plus g prime. So if you have, let's look at this example. Here we have x to the power of 4 plus x to the power of 6 and all of its derivative. So I can take their derivatives separately. Okay, so x to the power of 4 prime plus x to the power of 6 prime. Okay, I can write this like this. So let's do that. This is, let's put this 4 in front of x. It's 4x, 4 minus 1, it's 3 plus, when I put 6, x to the power of 6 minus 1, that is equal to 5. Let's continue with difference rule. So the derivative of f minus g is equal to the derivative of f minus the derivative of g. Okay, so we can take this also separately. So let's look at these examples. Here we have 4y to the power of 3 minus 2y, and its all derivatives is equal to, actually I can take these separately. Okay, so this one will be equal to 4y to the power of 3 and its derivative, the derivative of 4y to the power of 3 minus the derivative of 2y. Okay, so this is equal to, I put this 3 in front of 4, it will be 3 times 4, it's 12y to the power of 3 minus 1, that's equal to 2, right? Minus 2y, its derivative is equal to 2. When you 2y, it's 2. So let's look at this example. Here we have the derivative of y to the power of 4 minus y to the power of 2. Same logic. We can take their derivative separately. So here we have 4y. So 4 minus 1, it's equal to 3. So it's 4y to the power of 3 minus, this is 2. I put this in front of y. So this is equal to 2y. And this is 2 minus 1, which is equal to 1. and it will be 2y. So its derivative is equal to 4y to the power of 3 minus 2y. Let's continue with product rule. Here we have the derivative of f of x times g of x is equal to f prime x times gx plus f of x times g prime x. So when you multiply these two functions, and when you want to take its derivative, you first take the derivative of the first one times the second one plus the first one times the derivative of the second one. Okay, so let's look at this example. Here we have f of x is equal to x to the power of 2 minus 1, and g of x is equal to x plus 5. So let's find the derivative of their product. So it will be, let's write here, f of x times gx, and all of its derivative is equal to, so first we take the derivative of the first one, right, which is x to the power of 2 minus 1. So it will be, so let me write again, x squared minus 1, its derivative, times the second one, okay, it's x plus 5, plus the first one, it's x squared minus 1 times, this is x plus 5, the derivative of x plus 5, the second one's derivative. Oops, this is extra, sorry. So when we look at here, what do we have here? We have the derivative of x squared minus 1, it's equal to 2x, right? Because this is constant and its derivative is equal to 0. So, okay, let's continue. Here we have x plus 5 plus, here we have x squared minus 1, and times, here we have x plus 5, its derivative is equal to 1, right? Because x, its derivative is equal to 1, and 5, since it's constant, its derivative is equal to 0. So let's rewrite this again. So here we have 2x times x, it's 2x squared, plus 2x times 5, it's 10x, okay, plus it's x squared minus 1, and this is all equal to 2x squared x squared, it is 3x squared plus 10x minus 1. So this is the derivative of f of x times gx. Let's continue with this example. Here we have f of x is equal to 2x squared plus 6x minus 1 times 5x to the power of 3 plus x minus 2, and the derivative of f of 1 is asked. So as you can see, it doesn't have to be given as f of x times g of x. It can also be given like this, but you already know that this is the product of two functions, right? So you will do the same logic. So there, what was the formula for that? Let's say this is g of x, okay, this one, and let's say this one is m of x, okay. So how was the formula? It is equal to g of the derivative of g of fx, the derivative of the first one times the second one, okay, and then plus the derivative of the second expression here, second function, the derivative of m of x times the first one, g of x. Okay, so let's do that. Here we have, so let's look at this one, g of x. So its derivative is, we put this 2 in front of this one, so it will be 4x. Okay, when you put this 2 in front of 2x, it will be 4x, and 2 minus 1, it will be 1 plus 6, right? Because the derivative of 6x, it's 6, and since this is constant, its derivative is equal to 0, so I don't need to write that. So this is 4x plus 6 times m of x, which is equal to 5x to the power of 3 plus x minus 2 plus the derivative of m of x. So here we put this 3, so 3 times 5, it's 15. X to the power of 3 minus 1, which is equal to 2, right? Plus x, its derivative is 1. Since this is constant, I don't have to write it. It's equal to 0. Its derivative is equal to 0. So times g of x, which is equal to 2x squared plus 6x minus 1. Okay, so what was the question? It was the derivative of f of 1. So let's put 1 instead of x here. So when I put 1, it's 4 times 1, 4 plus 6, it's 10. 10 times, when I put 1 here, it's 5 plus 1, it's 6 minus 2, it's 4. Plus, when I put 1 here, it's 15 plus 1, it's 16 times 2 plus 6, it's 8 minus 1, it's 7. So it will be 40 plus 7 times 6, it's 42. 7 times 7, 4 plus 4, it's 11, and that will be equal to 152. Now let's look at quotient rule. So here we have the derivative of f of x over g of x is equal to the derivative of f of x times g of x minus the derivative of g of x times f of x over g of x to the power of 2. So let's look at this example. Here we have f of x is equal to 4x minus 2, g of x is equal to x squared plus 1, and the derivative of f of x over g of x is s. So let's begin by using our formula here. So first, we will take the derivative of the first one. So the numerator here, which is f of x, so let's do that. It is 4, right? The derivative of f of x is equal to 4 times the second function, the denominator, which is equal to x squared plus 1, okay, minus the derivative of the denominator, which is here equal to x squared plus 1, and its derivative, it's equal to 2x, right? Because you put this exponent in front of x, and it will be 2x, 2 minus 1, 2 minus 1, 1. That's why it's equal to 2x times f of x here, which is equal to 4x minus 2. And this is all over x squared plus 1 to the power of 2, right? The denominator, it's the g of x, so here it's x squared plus 1, and it's squared. So let's continue. Here we have 4x squared plus 4, and here we have minus, here we have 8x squared, and this is equal to minus 4x over, here we have x squared plus 1 to the power of 2. So this is our answer for our question. Let's continue with this example. Here we have f of x is equal to 1 minus 3x cubed over x squared plus 3. So the derivative of f of 0 is s. So first we will find the derivative of f of x, right? So we have here division. So let's say this one is g of x. Okay, this is our m of x. So how was the formula? It is equal to the derivative of the numerator first, the derivative of g of x here, times the denominator m of x, right, minus the derivative of the denominator. So here it's the derivative of m of x times g of x, okay, over, sorry, this is m of x square, okay. This was our formula. So let's apply this formula here. So the derivative of f of x is equal to the derivative of g of x. It is equal to this is 0 because it's a constant, and here we have 3. We will put this in front of this expression, and it will be minus 9x square, okay, because don't forget this minus sign. So when I put this 3 in front of 3x, it will be 9x, and 3 minus 1, it's 2. So it's minus 9x square times m of x, which is equal to x square plus 3, okay, minus, here we have the derivative of m of x. It is equal to 2x, right? We have here x squared, it's 2x, and 3, since it's a constant, it's equal to 0, times the numerator, it is equal to 1 minus 3x cubed over m of x squared. So it will be x squared plus 3 to the power of 2, okay. So what was the question? It was the derivative of f of 0. So let's put 0 instead of x. Here we will have, this will be, when I put 0 here, this will all equal to 0, right? So this is equal to 0, and this is also, since it's multiplication, this will be 0, so it will all equal to 0. So the numerator is equal to 0 over, here we have 0 plus 3, it's 3 to 3 square is equal to 9. So when you divide 0 by a number, this is equal to 0. Okay, here we have a very important rule. So let's say f of x is equal to g of x to the power of n. So here the function f is equal to another function to the power of n. Okay, so how we take its derivative? Its derivative is equal to, same thing first you do, you put this n in front of this expression, okay, then you write g of x to the power of, then you reduce the power of power by 1. Here same thing, n minus 1. But after that, it's not over yet. After that, you will take the derivative of the inside of this parenthesis, which is g of x, right? And then you take its derivative also after this one, okay? So let's look at this example. Here it says f of x is equal to x to the x squared plus x to the power of 4. So what is its derivative? So how we do that? First, let's write down here. So first you put this 4 in front of this expression, okay? So it will be 4x squared plus x. You don't need to change this one. X squared plus x, 4 minus 1, it's equal to 3 times, after this one you take the derivative of the inside of this parenthesis, okay, which is equal to 2x plus 1, right? The derivative of x is equal to 1. So this is the rule you have to apply. So let's look at this second example. Here we have f of x is equal to 5th root of x cubed plus 2 to the power of 2. So what is the derivative of f of x? So I can write this as, so I can write fx like this, x to the power of 3 plus 2 over 5, right? Because this is, I can write this, for example, if this is 5th root of a, I can write this as a to the power of 1 over 5, right? Since I have also 2 here, so I can write this as like this, so it will become a to the power of 2 over 5, okay? So okay, after this, it's much easier. So I put this 2 over 5 in front of this expression. When I take its derivative, so its derivative is equal to 2 over 5, okay, times x cubed plus 2. So 2 over 5 minus 1, it's equal to minus 3 over 5, okay, times, and after that I take the derivative of the inside of this parenthesis, okay. So this is, here we have x cubed and its derivative is equal to 3x squared. So this is the path you need to follow to get the right answer in this kind of questions. Let's look at this example. Here we have f of x is equal to square root of x cubed plus 3x plus 1 plus 5x, and the derivative of f of 0 is asked. So first we will find the derivative of f of x. So let's do that. First of all, I can write this f of x as x cubed plus 3x plus 1 to the power of 1 over 2, right, plus 5x. So let's take its derivative. It's equal to, so I put this 1 over 2 in front of this expression. It's 1 over 2 times, this will stay same, x cubed plus 3x plus 1 to the power 1 over 2 minus 1, it's equal to minus 1 over 2 times, after that I take the derivative of the inside of the parenthesis, okay. So its derivative is equal to, this is equal to 3x squared plus 3, right? Its derivative is equal to this, and plus we have here 5x and its derivative is equal to 5, okay. So after that I can put this 0 instead of x. So let's do that. The derivative of f of 0 is equal to 1 over 2 times, here we have 0 plus 0, it's equal to 0 plus 1 is 1, 1 over minus 1 over 2, it's equal to 1 times, when I put 0 here, it's 0 plus 3, it's 3 plus 5, and here we have 3 over 2 plus 5, and this is all equal to, it's 10 plus 3, it's 13 over 2.